Assalamualaikum dan salam sejahtera pada yang menonton video saya pada hari ini. Okay, kita jumpa lagi dalam video kita. So hari ini kita akan sambung lagi berkenaan dengan Fizik brain exercise kita, tapi soalan 4 lah. Okay, soalan 4 kita akan sambung lagi pada hari ini. Masih lagi dalam set 1. Okay, so without further ado, let us continue with our questions 4. Okay, so question 4. A, figure 2. Okay, now we have a figure here. We are given a figure. Kita diberi gambar kat sini. Figure 2 shows two blocks P and Q on a frictionless plane connected by a cord passing over a frictionless pulley. If the masses of P and Q are 100 kg and 50 kg respectively. 1. Sketch a free body diagram of block P. 2. Calculate the accelerations of block. 3. Calculate the normal force act on block Q. Okay, so the first question, we look at the first question. First question asking us to sketch a free body diagram. Okay, so let us take all the keywords, highlight all the keywords inside of the questions. Okay, let's see what is our keywords. Okay, frictionless. Okay, frictionless, what it means by frictionless? Okay, it states what frictionless because of, okay, this is a chapter 4. Chapter 4 stands for our forces. Chapter 4 forces. Question 4 is chapter 4 forces. Okay, so what is state of frictionless? Okay, why frictionless is a first keyword, is an important part because of it wants to state that there is no friction there. So kita dah ada belajar, we already learned 5 forces. 5 jenis force kan. Okay, we have weight, we have tension, we have external force. We have external force, we have friction, we have a normal force. So based on these 5 forces, so we already know that there is a frictionless. So when there is a frictionless plane, meaning there is no friction. So out of 5, we only have 4. Okay, so 4 is out and 1 is out, meaning no frictions. Okay, and then connected by a cord. Okay, actually I missed one here. Actually, it is a cord. Okay, cord also is a keyword here because of cord stand for a string. Okay, cord means string. Okay, so you have a string, meaning of course you have a tension. If you doesn't know what it means by cord itself, you can just look at the figure. Okay, the figure showing you that you have a string there. So when you have a string, so you already know that you have a tension. Okay, so over tension is confirmed, no frictions. Okay, out of 5, 1's confirmed, 1 out. Okay, another 3. So if the masses of P and Q are 100 kg and 50 kg, you are given a mass. Of course, automatically, if you have a mass, you stay on Earth. So what you experience the gravitational pull. So when you have gravitational pull, you have a weight. So you have a weight. So of course you already have a weight. So you have a tension, you have a weight. So 2 forces confirm. One force confirm out, which is friction. So another 2, either normal force or external force. So you are not the question are not telling you anything related to the external force. So of course there's no external force there. So no frictions, no external. So out of 5, 2 out. So there's 3 left. So 3 left means you already confirm have weight, you confirm have tension. So only 1 left, which is normal force. Okay, exists or not? So we need to look at the figure. Okay, sketch a free body diagram of the block P. So if you want to sketch a free body diagram, you need to know what types of forces acted on that object. So in this case, specific at block P only. Okay, so I'm focusing on the block P only. So in this case, look at our free body diagram. So here's our answers. Okay, so I still have our figure here attached here. Okay, so the blue one indicates a tension which resides inside of the string. Okay, ada tension yang ada dekat dalam tali. And then now, okay, the green one facing downward is your weight. Okay, based on the mass of the block P. So weight pointing straight downwards. Okay, so we have tension here. So is the blue one. Weight forcing downwards, which is a green one. And then what is the red one? Okay, the red one is a normal force. Okay, why normal force are facing like this? Because of, okay, you have a slanting plane. Okay, your plane is not perfectly horizontal or vertical. You have a certain degree there, 30 degree. So that means your plane is not 100% horizontal. It's not perfectly horizontal. When your plane on a certain angle, that means your normal force will follow. Because of what? Your normal force is actually 90 degree from the surface that you have a contact with. Normal force occurs when you have a contact. Okay, normal force wujud bila kita sentuh dua permukaan yang bersentuhan. So block P and the surface of the plane is in contact. Okay, when you have a contact, when you touching the block P touch the plane, so that means you have a normal force. But where is the directions of normal force? 90 degree out from that surface. So since the block itself are touching the plane, so 90 degree from the plane. So since the plane have a certain angle, so you must 90 degree from this plane. So out. So that is the directions of the normal force. So that's it. It's okay if you want to put the angle, or you doesn't want, it's okay. As long as you sketching the body diagram, you have the directions of the force correctly, you have the labeling the force correctly. Without labeling the angle, you still can get full marks. Okay, so but if you want to add up your angle, you are allowed to do so. It's very good because of it makes you have a better understanding. Okay, so next, look at our question part 2. Calculate the accessions of the block. Okay, blocks, accessions of the block, meaning both. Okay, both. Okay, so accessions of the block, and we need to know one thing: your accession is equal or same. Okay, block P and block Q have the same accession. Why? One thing, because of you are connecting with a same cord. You are connecting with the same string. Okay, sebab kita disambung oleh tali yang sama, sebab tu accession kita kena sama. And again, the word frictionless pulley is keyword that showing you that actually there's no friction here. When there's no friction here, so direction is exactly the same. Okay, there's no energy loss. Okay, so exactly if Q moving, P will follow. Okay, the directions will follow. Okay, now take out all the informations. MP 100 kilogram, MQ 50 kilogram, theta P 30 degree, theta Q 53. Okay, A is the things that we want to calculate. Okay, so we start with block P first. Okay, X component. Why I'm choosing X component? Okay, our X component is on the plane. Okay, horizontal plane. Our horizontal is on the plane. Okay, so F net equal to MA since we're moving. Okay, start with block P. So MP times with the G is our weight. Okay, this is our weight. Weight sine theta minus T equal to mass times with the acceleration. Okay, so why mg sine theta here minus T? Okay, so where is the directions? Okay, look back at the questions. So this is our block P. Okay, so actually y is minus T. Okay, block P and block Q, you doesn't know the directions. Okay, the figure are not stating the direction, but how do I know that it's moving? Okay, just think logically. You have two masses P and Q, 100 kilo and 50 kilo. P is much bigger than Q, so what you are thinking? So you are, who's gonna pull, who's gonna have the much forces, P or Q? Of course P, because of P have a lot of mass, 100 kilogram, which is 2 times bigger than Q. So that means Q will be pulling by the P. So kita akan ikut pergerakan P lah, sebab P lebih besar dia punya mass. Okay, so P akan bergerak ke sini. So bila bergerak ke sini, mass sin theta, okay, and weight, mg weight sin theta minus with the tension. So that is it. So this is our X component on the plane. So this is also our X component for the Q. So Q will moving upwards, P will moving downwards here. Okay, down the plane. Okay, so we look again. So F net equal to MA. So MPG sin theta minus T equal to MPA. Why I label MP? Because we have two masses here. So rearranging, find the T as a unknown. Okay, T on our left hand side. So T equal to MPG sine theta minus MPA. So this is our first equation. And now second equations in block Q, for block Q. So X component, again still using the same equation, F net equal to MA, our Newton seconds law. And then, so of course, since the first part, M weight sine theta minus T. So in this case, T should be minus our weight sine theta. So T minus MQG sine theta minus MQA, because of this is for block Q. So rearranging, we have T equal MQG sine theta plus MQA. So our second equation. So we have these two equations, we can equal because of both is the same T. Because of, like I said just now, before this, we have the same acceleration when we also have the same tension. Because of same tension, because of we are using the same chord. Okay. So 1 equal to 2. So MPG sine theta minus MPA. And then equal to MQG sine theta plus MQA. So we want to find our A. So make sure this A and this A is on the same side. Okay. See? To make it short, rearranging. So I hope that you know how to rearrange. Okay. So this is just basic mathematics. Okay. So this one I'm taking going here. Okay. Bring to the right hand side. This one I bring to left hand side. So from positive jadi minus. Okay, and this one from positive come here positive. So factorize, you get A, and you bring it on the left hand side, you have divide. So MP plus MQ. So substitute everything, make sure everything is in SI unit. And then you have A equal to 0.66 meter per second square. Okay, very simple. Okay, you must careful with these equations. First, make sure your free body diagram is 100% correct. Then second, you need to have your equation correct. Okay, so then you just have your mathematics and using your calculator. So you have 0.66 meter per second square. So that's it. And then proceed. Part 3, calculate the normal force acted on the block Q. So in this case, we are focusing on block Q. So normal force. So here keywords normal force on block Q. So focus on block Q. Okay. So we still using the same information. And here block Q. Okay. Since we want to have a normal force only acted on Y component. Okay. Look at here. So normal force should be that way. Okay, away from the plane. So this is our X component. So this is our Y component. Y component is 90 degree from the X. So since this is X, so this should be Y. Okay. That means block Q, Y component. Okay, F net equal to 0. Why F net equal to 0? Not equal to MA because of there is no acceleration in Y component. We are moving on X component only, not there's no motion in Y component. So that's why F net equal to 0 for Y component. And then N equal to mg cos theta. Okay, because of so equal for both forces is equal because of F net equal to 0. Okay, so N equal to 50. Substitute MQ is 50, G is 9.81, cos is theta is 53. So using calculator, calculate N equal to 295.19 Newton. Okay, so that's it. So part B. Okay, question 4 part B. Two masses M1 equal to 3 kg and M2 equal to 10 kg are connected by light string which passes over a smooth pulley as shown in figure 3. Calculate. Okay, in this figure we are given the directions of motion, so it's helping you a lot. Okay, so accessions of the system. So we need to calculate the accession of the system and tension in the string. Okay, so let us focus in the first part. We have a mass 3 kg, M2 another mass 10 kg. So M2 is much bigger than M1. So you can see here we are following the bigger mass. So since M2 is a 10 kilo, so this is why you are moving downwards, and M1 is going to be moving upwards. Connected to light string. So you have a light string there. String means you have a tension. You already have a tension, and you already have a mass. So you have a weight. So two forces already have. There's no and you've been told about smooth pulley. So pulley have no frictions, and then you are not on any surfaces, not touching any surface, no normal force, and then there's no stating anything related to surface, rough surface or smooth surface. There is no friction, and there is also no external force. So the only force exists is two forces, weight and the tension. Okay, so from here, acceleration, calculate the acceleration. We have M1 3 kilo, M2 10 kilogram. So what is our A? Okay, actually you are supposed to sketch first your free body diagram. Okay, so but I'm sorry, I'm not showing the free body diagram here because I just want to show you how you want to have understanding in reading the questions. Okay, so I'm not showing you on how you need to answer so that you can understand. Okay, it's just like I'm showing you the answers for how you writing down so that you have no careless, but to helping you in terms of understanding is the best for you to sketch a free body diagram first. Okay, so in this case I'm not sketching. Okay, I'm sorry for that. Okay, maybe I will show you how you sketch free body diagram in another videos. Okay, so block M1, so we are focusing on M1 first. So we have Y component. Yes, always acted on Y component sebab vertically kan. So vertically there's no horizontal, so Y component, and then we start with F not equal to MA. Therefore block M1, so your weight, so you are going upwards, so M1, so your tension bigger than your weight, so T minus your weight M1G might equal to M1K. So rearrange, you have T equal M1G plus M1 times A. So the first equation. Second equation from block M2, so again Y component, F net equal to MA, so you are moving downwards, your weight is bigger than your tension, so M2G minus T equal M2A. Rearranging, T equal M2G minus M2A. From here 1 equal to 2, so we have equation here, left hand side M1G plus M1A, right hand side M2G minus M2A. Rearranging, since we want to find our acceleration, so we have A equal to M2G minus M1G divided by M1 plus M2. Substitute everything, make sure everything is in SI unit. So 10 times 9.81 minus 3 times 9.81 divided by 3 plus 10. And we have A equal to 5.28 meter per second square. So that's it, it's very simple. Okay, so second part, tension in the string. Okay, tension in the string still have the same information. Okay, from 2, okay, so in this case, if we want to calculate our tension, so both tension on both mass is equal. Okay, maksudnya kita pakai tali yang sama, we still using the same string, so that means your tension on both mass is equal, M1 and M2. So it's up to you. You want to choose either equation 1 or equation 2. In this case, I'm choosing equation 2. Okay, so T equal to M2G minus M2A. So T, substitute everything. I have 45.3 meters. Okay, so that's it. Thank you for today. Thank you for still watching me, watching these videos. Thank you, and I hope that it's helped you a lot. If you have any questions, feel free to comment below. Okay, and you can ask me any question. If I will try to answering your questions, saya akan cuba untuk jawab. And then if you have any suggestions for upcoming videos, so feel free to comment so that I will try my best to try make a videos for you. Okay, so thank you, and if this video benefits for you, so please share with all your friends, and then thank you. So we'll see you in the next video. Bye.